So hi everyone, welcome back to another video, and we are discussing about the AWS Cloud Practitioner Essentials, in which we have this module 2, Compute in the Cloud. In the previous video, we have seen the basics of the cloud. In this video, we will be discussing about the EC2 service, SNS service, what are the requirements we have to run our virtual servers. So let's go ahead with the first slide, and it is here. So after the completion of this module, you can easily describe the EC2 benefits, identify the Amazon EC2 instance because we will be having different type of instances. We will be differentiating between the EC2 billing options, summarizing the auto scaling, load balancing, as well as we will be going to know the examples of load balancing as well as auto scaling. SNS we will be going to see simple notification service and simple queue service. And after that, we will be summarizing all the compute options whichever available. These are the topics which are going to cover today. That is the Elastic EC2 and EC2 instance type, pricing models, auto scaling, elastic load balancing, messaging service, serverless compute services, AWS container services, and we will not be taking the knowledge check today. As I already told you that we will be having the separate knowledge check video after the whole playlist. Moving ahead, this is the basic example of client and server model. For an example, this is the client which is coming to the barista. Barista is nothing but our waiter, right? If you go to any hotel, you will be having a waiter which comes to your table and ask you what do you want to order, and he will take that order and come back with your order, right? So this is the client and server model. Whatever the customer asks, barista will prepare or he will take it back to you, right? So first topic is our Amazon EC2, and we'll be going to discuss these all of the topics which I have already told you. Let's go ahead. So EC2, what is EC2? As you are going ahead with the cloud practitioner level, so we do not have to deep dive into it, but you should know all the services. Basically, EC2, S3, these are the most important services. After that, IAM is also one of the service which is very, very much important while you are going ahead for the uh, cloud practitioner level, right? So here, EC2 is nothing but your secure resizable compute capacity. It uses that. For an example, you are using a computer in your home, you are using your laptop to watch this video or any mobile phone as well. So it is having a kind of processor inside that, and it is your machine. Similarly, EC2 is also a machine on the virtual server. So you can say it has your virtual machine, right? So EC2 is nothing but your virtual computer where you will be having different folders. You will be having your memory storage, that is ABS is attached to the EC2 instance, right? So everything you do on your laptop that you can do on the EC2 as well. It is a kind of your virtual machine where you have the processor. You can choose any of the processor. You have different kind of processor, but for the free tier, you will be having the T2 dot micro over there. Then boot server instances and minutes. One important thing is if you want to terminate it, you can terminate it. If you want to stop it, you can stop it. As you can simply do whatever you are doing with your laptop. The similar thing you can do with the EC2 instance. Instance is nothing but your server, right? Pay only for what you use. See, you are running your server for 3 hours, you will be paying for 3 hours only. You are running it for 1 hour, you will be paying for 1 hour. So it is the basic funda over here. How Amazon EC2 works? Basically, we will be launching an instance. Launching an instance requires few of the steps that are. We will be selecting the machine. We have different AMIs. AMI is nothing but your Amazon machine image, right? So there are different AMIs which you will be selecting, and then the processor you will be choosing. Different kind of things you will be doing. What storage you want, what type of CPU you want. So that will be going to look forward in this video only. Then what we'll be going to do, launch an instance, then we can connect to that instance and use the instance. That is it. Similarly, you will plug in your instance, you will connect to it, and then you can use it for your processing or whatever you want to do. Then we will be going to look ahead for the EC2 instance types. First of all, I'll be giving you an example of it. For an example, there are three employees in your restaurant. One is taking the transaction process, one is making your coffee, and one is doing the order supply. Similarly, if you are having a very big company and you are having different teams, one is processing your finance, one is doing the IT work. So to remove the complexity of the work, we will be having different EC2 instances. Similarly, here we'll be having the different EC2 instances. Let us suppose this is one EC2 instance, this is two EC2 instance, this is third EC2 instance, which are having the different processes. and are used for different work, right? Moving ahead to our instance type. This is the basic question which is asked in the AWS Cloud Petitioner level. You will be given few options over there, and you have to identify which one is correct. For an example, over here they have given the general purpose, compute optimized, memory optimized. You will be given a question like a company wants a solution or a kind of instance for data warehousing, right? So which instance will be better for them? So general purpose, compute optimized, memory optimized, storage optimized, or anything else. So what you will be going to do, data warehousing. That means they are basically using the storage service over there. So that would be, we will be taking in consideration for the storage optimized. So here you can see general purpose. General purpose is nothing where you will be having everything in balance condition. For an example, balance compute, memory, and networking resources, then suitable for broad range of workloads. Like you want to do the general purpose of kind of things, then you can go hard for the general purpose, as the name itself says. Compute optimize, as the name itself saying, like you want to process your data in a very huge manner, then it offers the high performance processors. For example, you want to play the games, a kind of game where you want the compute process to be very high, then you will be using the compute optimized instance. Ideal for compute intensive applications and batch processing workloads, right? And memory optimize is nothing but your where it will be delivering fast performance for memory intensive workloads, well suited for high performance databases, right? Here we'll be having the memory optimized. Accelerated computing is there. It uses the hardware accelerator to expedite data processing, ideal for application streaming and graphic workloads. If you want video editing or you want to render something, then you will be going ahead with accelerated computing. Then storage optimize, it is also that particular thing which I was discussing about. The data, it is basically used for data warehousing as it is mentioned over here. So it offers the low latency and high IOPS. IOPS is nothing but your input output operations. For an example, if you are having a company where there are a lot of customers who used to input the data as well as they are fetching something, so there we'll be using the storage optimize. Suitable for workloads such as distributed file systems and data warehousing applications. So this is basically used for the data warehousing application. Remember one thing, they will be giving you an example and you have to identify that particular EC2 instance which is going to use in the solution, right? Let's go ahead. We have to match this. So ideal for high performance databases, which will be the correct answer for it. 1 to the C. Ideal for high performance databases. Let's see if it is. Yes, it is memory optimized. Then suitable for data warehousing application. Data warehousing we are talking about, so definitely it will be storage optimized. Let's see what is the answer. Yes, storage optimized. Third one, balances compute, memory, and networking resources, which is the correct answer. Then definitely balances means it is having everything in balance. Then it is the general purpose, right? So it is general purpose, right? Right. Offers high performance per processors, so we will be going to take the last one only, that is the compute optimized. Okay, so it offers us the high performance processor. So note it down if you want. These are the basic things which will be asked in the questions in the cloud practitioner, like which is the instance which is ideal for high performance database, so they will be selecting the memory optimized. Similarly for these all of, right? Now here are the pricing models which we will be going to discuss over here. Pricing model, let's see the first one, which is the on demand. Second is sport reserved. See, to learn these things, what you have to do is on demand. As you can see, we are saying about on demand. We are asking the AWS that I want the server now. So whichever I'll be choosing, that is the on demand. I want that, and it is having, it would be having a less downtime, and it will be having the high performance as well, and high availability. It depends on you as well if you are launching it in different availability zones as well. So it's a different part, but still, on demand is having no upfront costs or minimum contracts, as well as ideal for short-term irregular workloads. You want your application to run smoothly for a small period of time. Definitely, you can go ahead for the on demand, because here you will be reserving something for you for a particular specific time. It is much costlier than these two, right? Sport and reserve. Now, next one is spot, as itself name is saying spot. You are purchasing this instance at particular time, right? For an example, you already know what is bidding. Here as well, we'll be playing with the bidding. Suppose there is a EC2 instances which are not in use right now, and these instances you can purchase by bidding, right? For an example, already there's an EC2 instance which is available for $4. I'm taking an example, and you keep $5 over here. So you will be getting that instance for that particular of time where it would be up to $5 only. Let us suppose next people come up and they are giving $6, $7. So definitely the $7 person will get this EC2 instance, right? So we can say this kind of instance is ideal for the workload with flexible start and end times. We are having some kind of image processing application, so there we can use it. It will process immediately and will give you over saving over an on demand passes. Definitely, as it is a spot instance, then definitely it is very much cheaper than any of the instance whichever you will going to see. Spot is very much cheaper. That reserved instance, definitely, as the name itself saying, reserved means you are reserving an instance for a particular period of time. Here generally 1 or 3 years, right? I already told you that it requires a 1 year or 3 year of commitment. Definitely you will be going to choose a reserved instance over here. Now, compute saving plan is similar to that of 1 or 3 years of term commitment, which is the reserved instance. But here, it offer up to 66% savings over on-demand cost for a consistent amount of compute usage. Remember this thing, if they're asking you a particular saving on demand, then you will be going to choose compute savings plan. Dedicated instance means that you are reserving your instance and whenever you want to use, you can use it, right? Let us suppose you stop your instance, you terminated the instance. If you want to use that particular uh, address is reserved for you. An EC2 instance that runs in a VPC on hardware for a single customer, right? It is having the high security as well and higher cost compared to standard Amazon EC2 instances. Definitely, if you are reserving something for you, if you are reserving any address for you, then definitely it would be more costlier than any of the instance. But one instance is more, costlier than this one as well, which is dedicated host. A physical server with EC2 instance capacity for a single customer. Here we are reserving the whole server, right? A whole physical server we are reserving. So it is the most expensive Amazon EC2 option, right? So remember this thing between the difference of dedicated instance and dedicated host. In the dedicated host, we are reserving the whole server, but in the dedicated instance, we are reserving a particular address, right? Let's go ahead. Now, another thing is what is the difference between compute saving plan and spot instance? Again, I am going to tell you compute saving plans is similar to that of reserved instances, but it provides us a 66% on demand savings. Then spot instance is nothing but where we will be going to bid for a period of time. We are giving the higher prices to that instance, and definitely we can use it for that particular period of time until it reaches its whatever the bidding you have given, right? Then auto scaling. Very most important thing in this whole AWS is auto scaling, especially for the EC2 instance. Because, for an example, you go to any particular restaurant where you see there are two customers, and on the one side they have four customers. There is a single barista. Barista is nothing but your waiter who is serving to all of them. What can you expect? Would you get your food on time? No. So in this case, we will be having the scaling. We are talking about manual scaling for now. It is an example I'm giving. For the low demand, we will be having only one barista. If the demand goes high, if we got so many customers, then accordingly we'll be having the 2 to 3 baristas. We can reserve that. If we want two, we can put it two. If we want three, we can reserve the three. Right? So here as well, if there are two customers, we have only one waiter. If there are four customers, we are having two waiter, right? So this is the scaling which we are doing in the baristas. This is also known as horizontal scaling. Why horizontal scaling? Because we'll be having the same type of instances. Suppose our EC2 instance named as one instance, there would be multiple instances launched as one instance having the same configuration, right? Move ahead to the next one. Scale capacity as computing requirements change and use dynamic scaling and predictive scaling. So, as I already told you, order scaling is nothing but it will increase the EC2 servers as per the load, as per the demand, and you can use the dynamic scaling and predictive scaling automatically, which can predict like at what time your traffic can increase. It will automatically scale up your servers. So basically auto scaling gives you a lot of increment of the same type of servers, which we already know that it is already known as horizontal scaling, right? Move ahead to the Amazon EC2 scaling high demand. As already told you, there are four customers now. Two baristas is now open. Two baristas, nothing but your two servers. So minimum we reserve two, and then again we can scale as needed two more, right? We can give the capacity over here. What is your particular desired instances? You can give it two, and then in the maximum capacity you can define four. And whenever the traffic got increased, it will again launch the third one. Then if increase more number of people comes to your particular application, then it will launch the fourth one as well. Now, elastic load balancing. In the previous example, if let us see, if I have these four customers, I'm having two baristas. For an example, one male barista is basically focusing on these three, and this barista is focusing on one customer only. What would be the impact? Definitely, the impact would be he cannot serve to these three at particular time, right? One would be having 1 minute delay, one would be having 5 minute delay, and one would be having 10 second of delay, right? But in case if we want to distribute it accordingly, we can use the load balancing. That means we can distribute the load to the particular instances using the load balancer, right? So let's go ahead to the load balancer now. Load balancer is nothing but your where you balance your workload. Here you can see I was giving the example of it. One male barista is focusing on three and she is focusing on one. So definitely there would be reduced efficiency of this person, right? But if we distribute it accordingly, she will handle two. So definitely we will be having the more efficiency of the both the servers. So automatically distributes traffic across multiple sources, provides a single point of contact for your auto scaling group, right? If you have multiple servers, how you can have the single point by using the load balancing. As you can see the symbol as well here, I'm having a particular node having the three nodes which are connected to different instances, and this single node I can use directly, and I can deliver the traffic to that particular node, and it will be distributed accordingly wherever requires. Again, it used to do the health check as well. It used to send a particular signal and checks whether the particular server is running fine or not. If it is not running fine, then definitely it will distribute it according to the two, right? Right now we can see there are three. If one is not healthy, then it will distribute to the different two. Scalability and load balancing. So low demand period we have two customer, high demand period we have five customer. So accordingly, our elastic load balancing will be distributing the traffic to the auto scaling group. Auto scaling group is nothing but it is doing the horizontal scaling. We have two instances. If auto scaling group feels that there is more customer coming to it, it will launch two more instances, and this load balancer will distribute the traffic to four now. Okay, initially it was distributing to the two, and now it is distributing the four EC2 instances. So this is the basic work you need to know. So are these example of auto scaling or elastic load balancing? Let's see. Removes unneeded Amazon EC2 instance when demand is low. What is that? Auto scaling group. Adds a second Amazon EC2 instance during an online store's popular scale sale. That is again our auto scaling, then distributes workload across several Amazon EC2 instances, load balancer, ensure that no single EC2 instance has to carry the full workload on its own. Then again, it is a load balancer, auto scaling, auto scaling, auto scaling, and these three are elastic load balancer. Whenever we will be having the traffic increased on the particular instance, so we will be having the multiple instance launched uh, for the same particular instance type, right? So this is the horizontal scaling as well. Question can come up. What is auto scaling? There will be multiple options. You can choose this one. AWS messaging service, we can say it as SNS, where you will be having the message published to topics. Topic is nothing but your a kind of a box you can assume where you will be putting your messages, and subscribers immediately receive messages for their topics, right? Subscribers is nothing but your, it can be your service, it can be your mail ID. Here is an example. We have three customers who want coupon, who want coffee, who want new product. But one customer come up who only want the coupon. In this case, what you will do, you can again have another coupon, and you can distribute it. Here they want the three of them want three of the services. Coupon as well, coffee as well, and product. But one customer came up with like who only wants the coupon. So in this case, you will be having this coupon and you can give it. Similarly, we have SNS where we will be having the topics. This is the topic which is having coupon. This is the topic which is having coffee trivia. This is the topic which have new product. And the topic can be given to any of the service. Whether we want to deliver it to two services, we can directly attach it. If we want to deliver only one service, then we can deliver it accordingly. We can define multiple topics. Now, the simple queue service, name itself saying queue. Queue is nothing but your where you go to a train station where you want to purchase some ticket. So you will be standing in the queue. So in that case, here as well, you have simple queue service. If suppose your application is running, you are getting a traffic and your application used to process something. So in that case, if it is getting a lot of traffic, it is getting a lot of requests, so it will be processing it one by one, right? So this is the simple queue service. Send, store and receive messages between software components. Queue messages without requiring other services to be available. Let me explain you. Here is a customer who comes to the cashier, gives the cash to him, and then she gives the order to barista. She will tell that you have to take this particular coffee to the customer. Then she takes the drink to the customer and give it. Now, in case the barista is busy with another customer, so what will happen? A lot of customer will come to this cashier, and cashier will be having a lot of requests. In that case, barista is busy now. He will be coming and taking one by one orders, right? So the order will be delivered to him one by one. This is the queue. We'll be having the service. We want to deliver it. We have a lot of requests. So one by one, we can transmit the request. One by one, we get the request. This is the example. Customer orders. The order goes into the queue, and these are the queue. And the barista retrieves the order from the queue. Here, one by one, barista will pick up the order and deliver it to the particular customer. Now, the serverless compute services. Name itself saying serverless, right? We do not want to worry about the particular processor, particular storage optimized, nothing. You will be using the application. You do not have to worry about what is the processor is being used. You have to only pay for the application, right? You want to pay how much time you want to use, right? For that particular time, you will be paying. So these are our particular server. This is my laptop, which I'm running with the server. In case I do not want that, so this is my serverless computing. Here I'll be using only laptop directly without any servers. I am not worrying about it. AWS is handling that. First service is AWS Lambda. Lambda is nothing where you will be deploying your code. It is also having some servers in the backend, but the AWS is taking care of them. So run the code without provisioning or managing servers. Pay only for compute time while code is running. Use other AWS services to automatically trigger code. Again, this Lambda is run for 15 minutes. This is the disadvantage, but you can process it for the triggering purpose. Triggering is nothing but one particular service is sending something signal to it. It will trigger another service accordingly. So this is why it is used. It is a serverless, serverless computing method. The AWS Lambda is basically used. It is not having any server, but having the server in the backend, which is handled by the AWS only, you do not have to worry. Then how Lambda works? Upload your code to the AWS Lambda and set code to trigger from an event source, and the code runs only when triggered. So code will run only when it is triggered, and you will be paying only for the compute time use, right? Now container service. So application architecture, we have two, monolithic and microservice. Monolithic is nothing but where we have all the services all together combined and is hosted on a particular server. But microservice is nothing but where you will be having the different services and is launched on the different EC2 instances to reduce the workload. In this case, if any of the service got failed, then whole particular application will go down. In this case, if any of the component will go down, none of the other service get affect from it, right? So better one is microservice. Right now, all the companies are moving ahead for the microservices. As we have already seen the microservice. So in case of microservice, we cannot directly deploy that service. In this case, we need to define some containers for it. Why containers? Because different microservices can have different dependencies. And if I want to deploy that on a particular server, it may have different dependency, right? So in that case, uh, I'll be having some containers. In that containers, I'll be putting my images of that particular microservice, and then I can deploy. I can have different containers for different services, right? So this is our one case, that is one host with multiple containers. This is my host, which is having server and operating system, where I'm launching my applications, application 1 and application 2. So we can directly deploy the containers on that. Like it will increase the fault tolerance, as well as the different containers can handle the different dependencies, and we can run it smoothly. So for that, we have two services, Amazon ECS and EKS. ECS is nothing but your Elastic Container Service. If you are having your container, you want to run it, then you can directly use this Docker enabled application. Here we will be having the Docker installed, and we can directly deploy our containers on that, and we can run it. Again, we have this EKS. EKS is nothing but it is using the Kubernetes service. It runs the container on the Kubernetes and readily update application with new features. Now, one important thing that you must have to know is in these particular applications, if we are using the EKS and ECS, we'll be having two nodes. One is our worker node, one is our manager node. On the manager node, we will be deploying our EKS and ECS. But on the working node, we can have our own EC2 where we will be managing our server, auto scaling group and load balancing, everything we'll be doing. But if we do not want to worry about that, we want to use some serverless kind of service. In that case, we'll be having the FARGATE. FARGATE is nothing but another service from AWS, which is serverless. We can deploy the containers on it. We do not have to worry about increasing the number of instances whenever the loads get increased. On this particular FARGATE, we have to pay only for the particular time of usage, only for the particular type of load, right? So it run the serverless containers with Amazon ECS or EKS, pay only for the resources you use. Again, it is a serverless service. You can also use your EC2 instance as a worker node with the EKS and ECS. But if you want to use any serverless service on the worker node, then you can use this AWS Fargate. Now we have this knowledge check. We'll be dropping this knowledge check. This is all about this particular lecture. I hope you got something from this lecture. Definitely, these services from the compute in the cloud is sufficient to crack the cloud practitioner. Again, whatever the things I have explained you, just try to remember it. Just try to note it down. What are the things I have told you in this lecture, and prepare best. So thank you so much, and subscribe our Spentarn learning platform. Share it to your friends. Again, we have initially launched initiative from our side. If you want to improve your soft skill, if you want to improve your personality development, you can go ahead with that particular registration on our website. I can give you the link in the description. Go ahead and register for it. We will be giving you the training from the various MNC people. So thank you so much for joining us, and keep on learning.